and then we'll do them together. Can you all see them? Okay. And remember what you're asking yourself. Does order matter? Is repetition allowed? Another way to say repetition is allowed with replacement, that's repetition allowed, or without replacement, repetition is not allowed. You always are going to have, at least in these 4 types, indistinct objects. And we'll call them urns also, because we will call them urns down here at the bottom when I reframe them. What information is that telling you? Order matters. Good. Or permutation. Yeah. Order is going to matter here because I've named the people on the committee. So a president, if you're a president, it's different than if you're on the committee and a vice president. Okay. No individual can hold more than one office. What does that tell you? No repetition. Good. And those 2 things tell you this is a permutation. Good. A permutation of 26 things taken R at a time. So this should be 26P4 or 26 factorial over 26 minus 4 factorial. I mean, there's lots of ways you could write it. You could write it as 26 times 25 times 24 times 23. You don't have to simplify. What does the second one tell us? We still have the indistinct objects. That's not changing. That's true in all 4 of these problems. This time, we're going to select a delegation of 4 members. So I say distinct members. What is that telling you? No repetition. Yes. So you can't be on the committee twice. Once I have 4 unique people on the committee. Now, this is just a delegation where I omitted, I didn't say anything, but I omitted any kind of labeling. So the fact that you don't have any kind of labeling on this delegation, what does that tell you? No order. So this is a combination, 26C4 or 26 factorial over 26 minus 4. I'm just going to write it as 22 factorial, 4 factorial. Also known as 26, choose 4. Okay, what about this last one? A group of 26 members, they're my distinct objects, urns, requires volunteers to complete 4 distinct chores. The same person can volunteer for more than one job, and each job only requires 1 volunteer. So this 4 distinct chores, what does that tell you? So notice order matters, right? So notice in the one above, the distinct statement told us about repetition. Here, the distinct term tells us that order matters. It's kind of like that president-vice president thing. Now here, for more than one job, the same person can volunteer for more than one job. That tells us repetition is allowed. Good. So this is like the password, the 26 to the 4th, right? Okay, this last one is one we haven't discussed. So I'm curious how you think you should try this. But let's first identify things. A club consisting of 26 members, those are my distinct objects, volunteers to make 4 identical calls. What does that tell me? No order. Good. Order doesn't matter. And a member can volunteer for more than one. Repetition allowed. Okay, and we haven't filled that one out, right? We've talked about the other 3 cases, but we haven't talked about this. How do you think we should answer it? anybody have a guesstimate? Well, it's okay if you don't. I'm going to mute people because I'm hearing things. Okay. We're going to come down here and we're going to, or we'll come over here. First thing I want to remind you of, do you remember when we were doing the ways that we could do when we didn't have unique items like Texas, or Mississippi? Remember those? And we were counting all the ways we could switch those orders around. So if I had, let's say if I had, how would I find all the words I could come up with those 6 letters? Remember how we did it on Tuesday? I'm waiting. I'm going to wait you out. What are we going to divide by 4, Ed? So we're going to take all of these, which there are 6, and we're going to permute them. The problem is we're overcounting by all the permutations of the T's. How many permutations of the T's are there? 2, factorial. And we're going to divide out all the permutations of the E's. That's what Ed was getting to. So we're going to divide out that 4 factorial. So that was not quite a permutation because we had not distinct objects. But we were caring about the different arrangements, but we needed to make sure that we dealt with the non-distinct things, like the E's and the T's. Okay, so remember that in this next discussion. Okay, so now we're going to think of this problem here. The order doesn't matter and repetition is allowed. And we're going to first think about the distinct objects that we talked about, the 26 distinct objects, and we're going to create bins. Okay, so maybe we have 26 bins. Let's make it a little bit smaller. Let's pretend like we have 5 bins, just because I'm not going to want to draw all those bins. And let's just draw them. So we have 1 bin. I'm just going to try to minimize the number of bars I need. 1, 2, 3, 4, 5. Okay? Is everybody with me? There's my 5 bins. Distinct bins. Or we could even call them urns, because I do down the road. Now, I really don't need the ones on the end, right? I'm really just talking about, and you'll see why. I could write it like 1, 2, 3, 4. Okay? Where anything that's to the left of that bar is in the first bin. Anything to the right there is in the second, the third, the fourth, the 5th. Okay? So I only need these 4 bars to demark the 5 urns. Agreed? I don't need all 6. In fact, I don't want 6 is going to mess me up. Okay? Let's say now my what are we calling them? My identical calls. So I have 4 calls or 4 balls that are indistinguishable, which means they can all be in the first bin. I can spread them out into 4 of the bins, or some of them could be in 1 and, you know, so forth. I could put 2 here, nothing there, 1 there, nothing there, and 1 there. Okay? Which, remember how I don't need all those bars. So instead, what I've illustrated here, let me write this. That's the first bin, second bin, third bin, fourth bin, 5th bin. I would write it like this. That makes sense? So if I were to rewrite it all in one color, so how would I read this? This is telling me I have 2 bins in the first, none in the second, 1 in the third, none in the fourth, 1 in the 5th. Okay? Now, The reason I don't add the end bars, let's say I did, and then I wanted to talk about all the arrangements. What would this mean? Like, I don't even know what that means. That ball's not even in a bin if I have this extra bar here. Okay? You're going to ask that question in a minute. So tell me, I lost what I had here too. Tell me what this, translate this for me. Are you ready? Can somebody tell me what this says? Three in the first, nothing, 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 one in the last. Good. All right. Now I'm going to do the end things again. So if I decided to use all 6 bars that I had originally, what does that mean? Anybody? It doesn't have any meaning, right? Or it's just, I don't even know what it means, right? Where are those 2 balls? Outside of the bin? And you're like, well, I don't get where you're going with that. Well, if we now look at this and we talk about all the ways we could arrange the circles and the bars, or the balls and the bars, that's exactly like this up here, the TEE, right? I have this many letters. 4 of those bars are indistinguishable and 4 of those balls are indistinguishable, right? So if I wanted to count all the ways I can move the balls and the bars around, what do I have here? 8 factorial, but I want to divide out the permutations of those balls and the permutations of those bars, just like I would with the letters up there. Does that make sense? So if we're going to change this problem into one like the letters, we can't use 6 bars because we will arrive at, if I talk about all the ways I can move them around, with some sitting outside of a urn. That's why we only use 4 or 1 less. My last class had lots of questions, so the fact that you all don't scares me a little bit. Okay, so let's go back to this. If I had 20, let's go back to this question. If I have 26 members, remember those are my distinct urns, how many bars do I have? $25. So I'm going to have 26 minus 1 bars. Those are going to be the things that separate my urns. And I'm going to have 4 indistinguishable balls. So if I want to count all the ways I can do, it's all the bars plus the balls. So 26 minus 1 plus 4, permute them, and then divide out all the permutations of the indistinguishable things. The bars, 26 minus 1 factorial, and those. What if, tell me how to do this. I have n distinct bins, urns, sorry, I don't know why I keep wanting to call them bins, urns, and r indistinguishable balls. This tells me order doesn't matter and repetition is allowed. How many ways can I do it? This tells me I have n minus 1 bars This tells me I have R balls. Good, good. If I add these up, I have N minus 1 plus R bars and balls. So think of your letters. Like Mississippi, I had 11 letters. Here I have N minus 1 plus R letters. So I permute them all, and then I divide out the permutations of the indistinguishable things. N minus 1 factorial, boop, R factorial.